The room fell silent as I reached for the black silk blindfold. 27 pairs of eyes watched my every movement, some with skepticism, others with barely concealed anticipation. The device sat on the metal table before me, its red digital display counting down from 30 minutes, wires snaking between components like veins in a nervous system. Professor Hawkins had called it impossible. The entire advanced explosives engineering class had laughed when Marcus Chen suggested the challenge. But they weren't laughing now. Not when real money was on the table. Not when reputations hung in the balance. And definitely not when I had just agreed to defuse a live training device blindfolded in 30 seconds. Before we jump back in, tell us where you're tuning in from. And if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. My name is Sarah Elena Vasquez, and most people would never guess that the quiet graduate student who sat in the back row of every lecture, who barely spoke unless called upon, who dressed in oversized sweaters and kept her hair pulled back in a simple ponytail, had spent the last 6 years defusing improvised explosive devices in some of the most dangerous places on Earth. At 28, I carried scars that textbooks couldn't teach, and knowledge that came from the kind of education where mistakes meant body bags instead of failing grades. The morning had started like any other Tuesday at the Colorado Institute of Technology. I had arrived at Professor Hawkins' Advanced Explosives Engineering course 15 minutes early, claiming my usual seat in the back corner where I could observe without being observed. The classroom smelled of chalk dust and electrical components, a sterile academic environment that felt surreal after years of working in dust-filled compounds where the scent of cordite and fear hung heavy in recycled air. Professor James Hawkins was a good man, brilliant in his field, with 40 years of academic experience and a wall full of patents that had revolutionized mining safety protocols, but he had never knelt in a bombed-out building in Kandahar, sweat dripping into his eyes as he traced wire pathways with fingers that couldn't afford to tremble. He had never felt the weight of knowing that 6 soldiers were depending on his ability to render safe a device that some teenager had cobbled together from fertilizer and cell phone parts. Academic knowledge was clean, theoretical, safe. My knowledge was written in scar tissue and muscle memory. The other students treated me with polite distance. I was older than most of them, a transfer student who had appeared mid-semester with credentials that didn't quite add up to a traditional academic path. My transcripts showed coursework from places like Fort Belvoir and Eglin Air Force Base, institutions that specialized in teaching skills that universities preferred to discuss only in theoretical terms. When professors asked about my background, I kept my answers vague. Former military, specialized training, interested in pursuing civilian applications of explosive ordnance disposal techniques. It was all true, just edited for an audience that had never seen what a roadside bomb could do to an armored vehicle. Marcus Chen was different from the others. Where most students came from comfortable suburban backgrounds, Marcus carried himself with the restless energy of someone who had fought for everything he had achieved. His family had immigrated from Taiwan when he was 12, his father working double shifts at electronics assembly plant while his mother cleaned office buildings at night. Marcus had earned his way into CIT through pure intellectual force, graduating valedictorian from a high school where most counselors assumed students would be lucky to finish community college. He was brilliant, no question about that. His theoretical understanding of explosive chemistry was encyclopedic, his mathematical models for blast dynamics elegant and precise. But theory and practice were different countries, and I had lived in both. Marcus had the hunger of someone trying to prove himself. The kind of ambition that made him raise his hand first, speak the loudest, and challenge every assumption that professors presented as fact. He reminded me of some of the younger EOD techs I'd worked with. Smart kids who knew all the regulations but hadn't yet learned that sometimes the manual didn't cover what you found in the field. The tension between us had been building for weeks. It started small academic disagreements during classroom discussions. Professor Hawkins would present a case study of an explosive device, walking the class through the theoretical approach to neutralization. Marcus would offer his analysis, usually flawless from a textbook perspective. Then I would quietly raise my hand and suggest alternative approaches, methods that weren't in any manual but had been tested in situations where failure wasn't an academic exercise. Professor Hawkins seemed to sense there was more to my background than I was sharing, but he was too polite to push. The other students generally deferred to Marcus, who had established himself as the unofficial leader of our small cohort. But when I spoke, even reluctantly, people listened. There was something in my voice, a certainty that came from experience, that cut through theoretical debate and landed with the weight of truth. The breaking point came during a discussion of timed devices. Professor Hawkins had presented a scenario involving a hypothetical bomb with multiple redundant firing circuits, the kind of sophisticated device that might be encountered in a high-value target situation. Marcus immediately began sketching out solution trees, mapping logical pathways through the component hierarchy, calculating probability matrices for successful neutralization. His approach was methodical, academic, safe. Textbook perfect. It was also completely wrong for the real world. I found myself speaking before I had consciously decided to interrupt. That method would take 47 minutes minimum, assuming perfect conditions and no secondary surprises. Most devices like this are designed with tamper detection. You start following conventional logic trees, and you trigger a secondary firing circuit that nobody bothered to mention in your scenario. The classroom went quiet. Marcus looked up from his calculations, his expression shifting from concentration to irritation. That's a pretty specific assessment for a hypothetical situation, Sarah. Are you speaking from some kind of experience we should know about? There was challenge in his voice, the kind of academic posturing that I had learned to recognize and usually ignored. But something about his tone, the slight smirk that played at the corners of his mouth, reminded me of officers who had questioned my recommendations in briefing rooms, men who assumed that technical expertise had to come wrapped in the right accent, the right background, the right gender. I'm speaking from the understanding that real-world devices don't follow textbook assumptions, I said quietly. The people building these things aren't engineers working from approved specifications. They're using whatever materials they can find, whatever circuits they can improvise, whatever timing mechanisms they can acquire or build. Academic approaches assume rational design architecture. Field devices are built by people who want them to be as unpredictable as possible. Marcus set down his pencil and leaned back in his chair. Okay, Sarah. Since you seem to have insights the rest of us are missing, why don't you enlighten us? How would you approach this scenario? Professor Hawkins cleared his throat, sensing the tension but uncertain how to diffuse it. Perhaps we should move on to the next case study. But Marcus wasn't finished. No, I think this is important. Sarah keeps suggesting that our academic approaches are inadequate, but she's never actually demonstrated superior methodology. It's easy to criticize textbook solutions when you're not willing to put your own knowledge to the test. I could feel 26 pairs of eyes watching me, waiting to see how I would respond. Part of me wanted to deflect, to make some non-committal comment and let the moment pass. I had learned long ago that sometimes the smartest thing to do was let other people underestimate you. But there was something in Marcus's tone, a dismissiveness that triggered memories of every time someone had questioned my competence, based on assumptions about what kind of person could master the complex technical skills required for explosive ordnance disposal. What kind of test did you have in mind? I asked. Marcus smiled, the expression of someone who thought he had just gained the upper hand. Professor Hawkins has a practice device in the lab. Training model, same components as real EOD equipment, but with safety interlocks. Multiple firing circuits, randomized wire configurations, timer mechanism. Standard certification level complexity. Professor Hawkins looked uncomfortable. Marcus, I'm not sure that's appropriate for a classroom setting. It's perfect for a classroom setting, Marcus continued. Academic theory versus practical experience. Sarah can demonstrate these superior field techniques she keeps referencing, and we can all learn from watching an expert work. The challenge hung in the air like smoke from a discharged weapon. I could accept it and risk exposing skills that I preferred to keep private, or I could decline and confirm Marcus's implication that my knowledge was more theoretical than practical. Either choice carried risks, but one carried the additional burden of letting someone else's assumptions about my capabilities go unchallenged. Fine, I said. But if we're going to do this, let's make it interesting. Marcus raised an eyebrow. What did you have in mind? Standard EOD certification requires successful neutralization within 12 minutes. You've been questioning whether field techniques are superior to academic methods. So let's test both approaches. You take the first attempt using your systematic textbook methodology. I'll take the second attempt using field protocols. The classroom erupted in murmurs. Professor Hawkins looked like he wanted to shut down the entire discussion. But academic curiosity was warring with professional caution. Marcus's expression shifted as he realized that the challenge had suddenly become mutual. That seems fair, he said slowly. "But what makes it interesting?" I had spent enough time around soldiers to know that respect was earned through demonstration, not declaration. If Marcus wanted to test my knowledge, he was going to learn that field experience came with confidence that couldn't be found in any textbook. "Blindfolded," I said quietly. 30 seconds. The room exploded in conversation. Professor Hawkins stood up from his desk, his academic composure finally cracking. "Absolutely not. Sarah, that's completely irresponsible. These devices may have safety interlocks, but they're still potentially dangerous. Blindfolded neutralization in 30 seconds isn't just difficult. It's impossible." Marcus was staring at me with an expression I couldn't quite read. "Sarah, are you serious? 30 seconds blindfolded? Even if you have some kind of military background, that's not humanly possible." "Then you shouldn't have any trouble winning the challenge," I replied. The students were talking over each other now, voices raised in excitement and disbelief. Some were already pulling out phones to record whatever was about to happen. Others were shaking their heads, convinced that they were about to witness either an impressive demonstration or a spectacular failure. Professor Hawkins was trying to restore order, but academic authority was a fragile thing when faced with the prospect of watching something that existed outside the boundaries of conventional education. These students had spent years learning theories and formulas, studying case studies, and running computer simulations. The chance to see real expertise in action was too compelling to ignore. "Wait," called out Jennifer Walsh, a third-year student who rarely spoke up during class discussions. "If we're going to do this, shouldn't there be stakes? I mean, if Sarah is really confident enough to attempt blindfolded neutralization, and Marcus thinks it's impossible, maybe they should both put something on the line." Marcus nodded slowly. "Jennifer's right. What are we betting?" I had not intended for this to become a formal wager, but the momentum of the situation was carrying us forward whether I wanted it to or not. 27 students were waiting to see what kind of stakes would make this challenge meaningful. $500, I said. "Each." The number hung in the air like a challenge flag. $500 was serious money for graduate students, enough to matter but not enough to destroy anyone financially. It was the kind of sum that transformed a classroom demonstration into something with real consequences. Marcus was quiet for a long moment, calculating odds and considering options. His theoretical knowledge was encyclopedic, his academic performance flawless. But something in my voice, some certainty that came from sources he couldn't identify, was making him hesitate. $500 says you can't neutralize a live training device blindfolded in 30 seconds, he said finally. $500 says I can, I replied. Professor Hawkins made one last attempt to restore sanity to his classroom. This is completely against university policy. If anyone gets hurt, if there's any kind of accident, the liability issues alone. Professor, I said gently, these are training devices designed for student use. They have multiple safety systems and automatic shutoffs. The only risk is embarrassment. That wasn't entirely true. Even training devices carried some element of danger if mishandled. But I had worked with real explosives in real combat situations, and the level of risk represented by a classroom training device was so far below my normal operational parameters that it felt like playing with toys. More importantly, I was tired of being polite, tired of keeping my capabilities hidden, tired of letting people make assumptions about what I could or couldn't do based on their limited understanding of what was possible. Marcus was already moving toward the door. Lab's 2 floors down. Training devices are in the secured cabinet. Professor, you have access codes, right? Professor Hawkins looked around the classroom at 27 faces filled with anticipation and excitement. Academic curiosity had always been his weakness, and the chance to see theoretical knowledge tested against practical expertise was too tempting to resist. Fine, he said, gathering his papers with the resigned air of a man who had just made a decision he might regret. But we do this properly. Full safety protocols, video documentation, and if anyone so much as thinks about posting this on social media before I review the footage, they'll be explaining themselves to the dean. The migration from classroom to laboratory took 15 minutes. Professor Hawkins needed time to unlock security cabinets, verify safety systems, and set up recording equipment. The students used the time to place side bets, debate the likelihood of success, and speculate about the mysterious background that had given their quiet classmate the confidence to attempt something that sounded impossible. The laboratory was a sterile environment of white walls and stainless steel surfaces, designed for precise work under controlled conditions. Nothing like the dusty compounds and improvised workspaces where I had learned my trade, but the fundamental principles remained the same. Explosive devices were puzzles built from common components arranged in uncommon ways. The key to solving them was understanding not just how they worked, but how the people who built them thought. Professor Hawkins placed the training device on a metal table under bright LED lighting. It was a sophisticated piece of equipment, designed to replicate the complexity of real-world threats while maintaining safety margins that would prevent serious injury in case of student error. Multiple wire bundles connected various components. Timer displays showed digital readouts, and indicator lights provided visual feedback about system status. Marcus studied the device with the intensity of someone who understood that his reputation was about to be tested. His knowledge was comprehensive, his methodology sound. Under normal circumstances, his systematic approach would probably result in successful neutralization within the 12-minute certification standard. But these weren't normal circumstances. The presence of an audience, the pressure of a wager, and the knowledge that his competence was being directly compared to someone with mysterious credentials were all factors that could affect performance. I had seen seasoned professionals crack under less pressure. Professor Hawkins finished his safety checklist and stepped back from the device. "Marcus, you're up first. 12-minute maximum standard certification protocols. Device is armed and active. Timer set for 30 minutes. Your goal is to render it safe before the clock runs out." Marcus approached the table with visible confidence, but I could see tension in his shoulders, a slight tremor in his hands that suggested nerves were beginning to affect his motor control. He began with textbook methodology, tracing wire pathways, identifying component relationships, building a mental map of the device architecture. His approach was methodical and logical. He identified the primary firing circuit, located the timer mechanism, traced power distribution pathways. Each step followed established protocols, each decision based on sound theoretical principles. If this had been an academic exercise, his performance would have earned top marks. But real devices weren't built by academics. They were constructed by people who understood that predictability was a weakness, that following logical pathways was exactly what bomb disposal experts were trained to do. The training device had been programmed with realistic complications, secondary circuits and dummy pathways designed to confuse conventional analysis. Marcus worked steadily for 11 minutes and 43 seconds before successfully neutralizing the device. A solid performance that demonstrated mastery of theoretical principles and competent technical execution. The other students applauded, and Marcus stepped back from the table with visible relief and justified pride in his accomplishment. Professor Hawkins reset the device, randomizing wire configurations and reactivating all systems. The challenge was identical in complexity, but different in specific details, exactly the kind of variable that separated academic exercises from real-world applications. "Sarah," Professor Hawkins said quietly, "you can still change your mind. No one expects you to actually attempt this blindfolded. The demonstration value has already been achieved." I picked up the black silk blindfold that someone had procured from the theater department. The fabric was soft between my fingers, expensive material that would block all visual input while remaining comfortable during extended wear. Not that I would need extended wear time. 30 seconds, I said, looking around the laboratory at faces filled with skepticism and curiosity. Timer starts when the blindfold goes on. Professor Hawkins nodded reluctantly and positioned himself near the device controls. Safety systems are active. Automatic shutoff if you trigger any tamper detection circuits. Video recording is running. Marcus has the stopwatch. I had learned long ago that confidence was as much about mental preparation as technical skill. The device in front of me was a puzzle built from familiar components arranged according to logical principles. The fact that I couldn't see it was less important than most people assumed. After 6 years of working with explosive devices, my fingers could read circuits like other people read text. The blindfold settled over my eyes, blocking out the bright laboratory lighting and reducing my world to sound and touch. I heard Professor Hawkins arm the device, heard the quiet hum of electronic systems coming online, heard Marcus start the stopwatch with a sharp click. Time slowed down the way it always did, when everything mattered and nothing could be taken back. My hands moved to the device with practiced precision, fingertips reading the surface topology like Braille. The metal casing was warm from the electronic components inside, smooth except for the textured areas around connection points and access panels. I could feel the vibration of the internal timer mechanism, a subtle tremor that told me the countdown was active and steady. 28 seconds remaining. The first wire bundle was exactly where my spatial memory had mapped it during my visual inspection. 6 conductors wrapped in colored insulation, but color meant nothing now. What mattered was the sequence, the electrical pathway from power source to detonation circuit. My index finger traced the bundle from its origin point, following the copper pathways that would carry the signal when the timer reached 0. In the darkness behind the blindfold, I could hear breathing from 27 people who had suddenly forgotten how to exhale properly. Someone's phone was recording, the tiny whir of a cooling fan audible in the forced silence. Professor Hawkins was standing close enough that I could smell his aftershave, a nervous energy radiating from his position near the emergency shutoff controls. 25 seconds. The primary firing circuit was a textbook configuration. Exactly the kind of setup that Marcus would have identified and neutralized using conventional methodology. But textbook configurations were often camouflaged for secondary systems, backup pathways designed to catch disposal experts, who assumed that obvious solutions were correct solutions. My left hand found the timer housing while my right hand continued mapping wire pathways. The digital display was warm against my palm, heat signature indicating active electronics. The countdown mechanism was mechanical, not electronic, which meant that simply cutting power wouldn't stop the detonation sequence. I needed to find the interrupt circuit, the pathway that would signal the timer to abort before reaching 0. 22 seconds. There it was, a thin wire, smaller gauge than the primary conductors, running parallel to the main bundle but separated by a quarter-inch of space. My fingertip followed its path from the timer housing to a small relay switch positioned behind the primary components. This was the interrupt circuit, designed to receive an abort signal from a remote detonator or a disposal technician who knew what to look for. But the wire was trapped beneath the primary bundle, inaccessible without first disconnecting the main firing circuit. A classic catch-22 that would force conventional disposal methodology into a time-consuming sequence of systematic disconnections. Marcus had probably spent 8 of his 11 minutes working through this exact problem, carefully isolating each conductor to avoid triggering tamper detection circuits. 19 seconds. I didn't have 8 minutes. I had 19 seconds and a room full of people who were beginning to understand that they might be witnessing either a demonstration of extraordinary skill or a spectacular failure. The difference between those outcomes lay in my willingness to trust knowledge that couldn't be found in any manual, techniques that had been developed through necessity rather than theory. My right hand moved to the power coupling while my left hand maintained contact with the timer housing. The coupling was a standard industrial connector, designed for quick disconnection but secured with a locking mechanism that would require deliberate manipulation to release. Conventional wisdom said that disconnecting power while the system was active would trigger immediate detonation through a deadman switch. Conventional wisdom was often wrong. 16 seconds. The power coupling had a secondary contact, a tiny auxiliary connector that carried monitoring signals back to the primary circuit. Most disposal experts ignored auxiliary contacts, focusing on the obvious high-voltage pathways that carried detonation signals. But monitoring circuits were two-way streets, and someone who understood signal architecture could use them to send commands instead of just receiving status updates. My thumb found the auxiliary contact while my fingers positioned themselves on the primary coupling release. This was the moment where theory diverged from practice, where textbook knowledge gave way to the kind of understanding that came from working with devices built by people who thought like engineers but operated like guerrilla fighters. 13 seconds. I could hear Marcus breathing behind me, shallow and quick. He understood enough about explosive ordnance disposal to recognize that what I was attempting fell outside the boundaries of conventional methodology. The other students were completely silent now, the weight of real consequences finally settling over their academic excitement. Professor Hawkins cleared his throat nervously. "Sarah, perhaps you should." "Quiet," I said softly, not from arrogance but from necessity. Auditory input was crucial now, my ears filtering the electrical sounds of active circuits from the background noise of human presence. The timer mechanism had a distinct harmonic signature, a frequency that would shift slightly when the countdown entered its final sequence. 10 seconds. My thumb pressed the auxiliary contact while my fingers began the precise sequence of movements required to release the primary coupling without triggering tamper detection. The auxiliary circuit carried a 12-volt monitoring signal, exactly the voltage level required to activate the interrupt relay if the signal was reversed and amplified through the coupling's secondary contact. It was elegant in its simplicity, the kind of solution that emerged from understanding systems architecture rather than memorizing procedural steps. The device's designers had built in multiple failure modes, but they had also created pathways for unconventional solutions. The trick was recognizing which pathways led to success and which led to immediate detonation. 7 seconds. The coupling released with a soft click, and I felt the power drop across the primary circuit. But instead of triggering the dead man switch, the auxiliary contact carried my reversed signal directly to the interrupt relay. The timing had to be precise. The signal amplitude exactly calibrated to activate the abort sequence without overloading the monitoring circuit. 5 seconds. The timer mechanism's harmonic signature shifted, the steady countdown rhythm interrupted by the abort signal. I felt the relay engage, a tiny mechanical click that was barely audible but unmistakably final. The device was safe, all firing circuits disabled. Countdown sequence terminated. 4 seconds, 3 seconds, 2 seconds, 1 second, 0. The laboratory remained intact. 27 graduate students remained intact. My reputation, whatever it might be worth, remained intact. I reached up and pulled off the blindfold, blinking in the sudden brightness of LED lighting that seemed harsh after 30 seconds of darkness. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The silence stretched for what felt like minutes, but was probably closer to 15 seconds. Marcus was staring at the stopwatch in his hand, as if it had just revealed secrets of the universe. Professor Hawkins was looking back and forth between me and the device, his academic worldview struggling to process what he had just witnessed. How? Marcus finally managed to say, "How is that possible?" I set the blindfold on the table next to the now safe training device. Different training, different methodology. Field techniques aren't better than academic approaches, they're just designed for different operational requirements. Jennifer Walsh was the first student to find her voice. "Sarah, that was incredible. I've never seen anything like that. Where did you learn to do that?" The question I had been avoiding for months hung in the air between us. These people had just watched me demonstrate capabilities that existed outside their understanding of what was possible within their field of study. They deserved some kind of explanation, even if I couldn't provide the complete truth. "Military training," I said simply. "Explosive ordnance disposal, 6 years active duty, multiple deployments, specialized certification in improvised explosive device neutralization." Professor Hawkins was nodding slowly, pieces of a puzzle finally clicking into place. "That explains the transfer credits from military institutions." "Sarah, why didn't you mention your background when you enrolled?" EOD experience is exactly the kind of practical knowledge that enhances academic research. Because military experience carried baggage that academic environments often couldn't handle. Because explaining where I had learned these skills meant talking about places and situations that made civilian audiences uncomfortable. Because the transition from military to academic life was complicated enough without advertising capabilities that set you apart from your peers. I wanted to focus on the academic aspects of explosive engineering, I said. Military experience is useful, but it's not the same as understanding the theoretical foundations that drive technological development. Marcus was still holding the stopwatch, still staring at the numbers displayed on its screen. 29.4 seconds. You did it in 29.4 seconds. The margin of error was larger than I preferred, but well within acceptable parameters for a demonstration. In real operational situations, I had successfully neutralized devices with time margins measured in single-digit seconds. The luxury of having nearly 30 seconds to work with had actually made the process feel almost leisurely. "The bet?" Jennifer said suddenly. "Marcus, you owe Sarah $500. Marcus looked up from the stopwatch, his expression cycling through several emotions before settling on something that might have been respect. "Yeah, I do. Sarah, I apologize. I made assumptions about your capabilities based on limited information. That was unprofessional and unfair." The apology was genuine, and I appreciated the maturity it demonstrated. Academic environments were competitive by nature, but the best students were those who could recognize superior knowledge without letting ego interfere with learning opportunities. The money isn't important, I said. What matters is understanding that there are multiple approaches to solving complex problems. Academic methodology provides the theoretical foundation, but practical application sometimes requires techniques that aren't found in textbooks. Professor Hawkins was examining the device, tracing the wire pathways that I had manipulated during the neutralization sequence. Sarah, would you be willing to explain your methodology? The technique you used to reverse the auxiliary signal. I've never seen anything like that in any literature. That was because the technique had been developed by Staff Sergeant Maria Rodriguez during a deployment to Baghdad, refined through field testing by soldiers who needed solutions that worked faster than conventional approaches allowed. It had been passed down through informal networks of EOD specialists, shared during late-night briefings and equipment maintenance sessions, never formally documented because it fell outside approved operational procedures. It's based on understanding that monitoring circuits can carry command signals if you reverse the voltage polarity and amplify the signal through secondary contacts, I explained. Most disposal experts ignore auxiliary circuits because they're not part of the primary firing sequence, but device builders use them for status monitoring, which means they're connected to control systems. If you understand the circuit architecture, you can use monitoring pathways as command pathways. The explanation was technically accurate, but deliberately simplified. The full methodology involved understanding signal propagation through multiple circuit layers, calculating voltage requirements for relay activation, and recognizing harmonic signatures that indicated successful abort sequences. It was knowledge that came from working with hundreds of different devices, learning to read electrical systems the way other people read facial expressions. Marcus was taking notes, his earlier competitiveness replaced by genuine intellectual curiosity. That's brilliant. It's completely outside conventional EOD doctrine, but the logic is sound. Why isn't this taught in standard training programs? Because standard training programs were designed to minimize risk through systematic procedures, not to maximize speed through innovative techniques. Because military doctrine favored predictable outcomes over creative solutions. Because the people who developed these methods were field operators, not academic researchers, and their knowledge was transmitted through mentorship rather than formal publication. Military training emphasizes procedural compliance, I said carefully. Creative problem-solving is encouraged, but within established safety parameters. The technique I just demonstrated carries higher risk than conventional approaches. It works, but it requires experience and judgment that can't be easily systematized. Professor Hawkins was still studying the device, following wire pathways with his finger. The risk assessment is fascinating. You essentially bet that the designers had included specific circuit redundancies, and that those redundancies could be exploited through unconventional signal routing. If you had been wrong about the circuit architecture, immediate detonation, I finished. But I wasn't wrong. Device architecture follows logical principles, even when those principles are concealed through complex wiring schemes. The key is understanding not just how circuits work, but how the people who build them think. That was the real difference between academic knowledge and operational experience. Textbooks taught you about components and procedures, but they couldn't teach you about the human element, the psychology of device builders who were trying to outsmart disposal experts. Real expertise came from understanding your opponent, learning to think like someone who wanted their creation to be as unpredictable as possible. The laboratory had become a classroom. Within a classroom, 27 students gathered around a training device that had just been transformed from academic exercise to practical demonstration. Questions flowed freely now, technical inquiries about signal routing and voltage calculations mixed with broader curiosity about the intersection of theoretical knowledge and real-world application. I found myself answering with more openness than I had shown since enrolling at CIT. These students had earned the right to understand the broader context of what they were studying. The reality that explosive ordnance disposal was more than an academic subject for some people. Their questions were intelligent and respectful, driven by genuine desire to learn rather than simple curiosity about military experience. Marcus approached me as the group discussion began to wind down. Sarah, I want to apologize again for how I approached this whole situation. I let competitiveness override professionalism, and that was wrong. But I also want to ask you something. I waited for him to continue. recognizing the tone of someone who was building up to a significant request. Would you be willing to work with me on a research project? My thesis is focused on developing new approaches to improvised explosive device neutralization, specifically techniques that could reduce disposal time while maintaining safety margins. Your practical experience could provide insights that pure theoretical research can't achieve. The offer was tempting for several reasons. Marcus was genuinely brilliant, his theoretical knowledge extensive and precisely organized. A collaboration between academic research and operational experience could produce innovations that neither approach could achieve independently. More importantly, it would provide a legitimate reason for me to share knowledge that I had been keeping carefully contained. But collaboration meant exposure. Detailed discussions about techniques and experiences that I had learned to keep private. Academic research required documentation, publication, peer review, all processes that would make my background more visible than I preferred. The transition from military to civilian life was complicated enough without advertising capabilities that made people ask uncomfortable questions. Let me think about it, I said finally. Research collaboration requires significant time commitment, and I'm still adjusting to academic schedules and expectations. Marcus nodded, understanding that the request involved considerations beyond simple academic partnership. Of course, take whatever time you need. The offer remains open. Professor Hawkins was packing up his recording equipment, the documentation process that would allow him to review what had just occurred and decide how much of it belonged in official academic records. The demonstration had been educational, but it had also raised questions about curriculum standards and safety protocols that would require careful consideration. Sarah, he said, as students began filing out of the laboratory, would you be available for a brief conversation in my office later this week? I'd like to discuss how your background might contribute to our program and whether there are opportunities for you to share your expertise with other students. Another offer that carried both opportunity and risk. Contributing to academic programs meant visibility, recognition, the chance to influence how the next generation of explosive ordnance specialists would be trained. But it also meant questions about my background. Requests for detailed explanations of techniques that I had learned in situations that civilian audiences often found difficult to understand. I'd be happy to discuss that, I said, the response automatic and polite even while my mind was calculating the implications of deeper involvement with the academic community. The laboratory emptied slowly, students reluctant to leave after witnessing something that had expanded their understanding of what was possible within their field of study. Marcus lingered near the door, clearly wanting to continue our conversation but recognizing that the moment had passed. Professor Hawkins secured the training device and completed his documentation, his movements careful and methodical. I remained at the table where the device sat, its components now safe and inert, wires and circuits that had briefly held the potential for demonstration or disaster. In 30 seconds, I had moved from being a quiet graduate student who preferred anonymity to being someone whose capabilities were now known to 27 people who would undoubtedly share the story with others. The change was irreversible, the careful privacy I had maintained since enrolling at CIT now compromised by my own decision to accept Marcus's challenge. But as I looked around the empty laboratory, at the equipment that represented the intersection of theoretical knowledge and practical application, I realized that hiding my background had been a form of self-imposed limitation. These people deserved to understand that explosive ordnance disposal was more than an academic subject, that the techniques they were learning had been tested in situations where failure meant casualties, not failing grades. My experience could contribute to their education in ways that textbooks and simulations could never achieve. The question was whether I was ready to step out of the shadows and accept the responsibilities that came with being recognized as an expert in a field where expertise was measured in lives saved, rather than grades earned. The walk back to my apartment that evening felt different somehow, as if the familiar campus pathways had been rearranged while I wasn't paying attention. Students passed me with the same casual indifference they had shown for months, unaware that their quiet classmate had just demonstrated capabilities that existed far outside the normal boundaries of graduate school experience. But I could feel the weight of changed circumstances. The knowledge that my carefully maintained anonymity had been voluntarily sacrificed for 30 seconds of professional validation. My phone buzzed with text messages as I climbed the stairs to my second-floor apartment. 3 messages from Jennifer Walsh, asking technical questions about signal reversal methodology. 2 from other classmates requesting clarification about specific aspects of the neutralization sequence. 1 from Marcus that simply read, Thank you for making me a better engineer today. I set the phone aside without responding and moved to the kitchen window that overlooked the campus quad. Students were scattered across the grass in small groups, some studying, others just enjoying the mild evening weather. Normal college life continuing its predictable rhythm while I processed the implications of a decision that had irrevocably altered my position within that community. The apartment was sparse, furnished with the kind of generic furniture that came with graduate student housing. No photographs on the walls, no personal decorations that might reveal too much about my background. I had learned to live lightly, to avoid accumulating possessions or relationships that would be difficult to leave behind if circumstances required sudden departure. Military habits died hard, even in civilian environments. But as I stood at the kitchen window watching normal people live normal lives, I realized that my commitment to anonymity had been more than just operational security. It had been a form of protection against the weight of expectations that came with demonstrated expertise. In military environments, competence was expected, and exceptional performance was simply part of the job. In civilian academic settings, the same capabilities carried different implications. The device I had neutralized that afternoon was a training model, designed for educational purposes with multiple safety systems and automatic shutoffs. But the technique I had demonstrated was real, developed and refined through necessity in situations where failure meant body bags instead of failing grades. The 27 students who had witnessed my performance now knew that their quiet classmate possessed knowledge that came from places they had never seen, experiences they had never faced. My laptop chimed with an email notification. Professor Hawkins, writing to confirm our meeting for Thursday afternoon and attaching several research papers that he thought might interest me. Academic articles about innovative approaches to explosive ordnance disposal, theoretical frameworks for improving neutralization efficiency, mathematical models for predicting device behavior under various environmental conditions. I scrolled through the abstracts, recognizing the authors' names from my previous research into civilian applications of military EOD techniques. Brilliant work, all of it, but limited by the constraints of academic methodology. Researchers who understood the theoretical foundations, but had never knelt in a dusty compound with sweat dripping into their eyes, while 6 soldiers waited for them to render safe a device that some teenager had cobbled together from fertilizer and cell phone parts. The gap between academic knowledge and operational reality was vast, but it wasn't unbridgeable. Military experience could inform civilian research, and academic rigor could refine field techniques that had been developed through trial and error rather than systematic analysis. The challenge was finding ways to combine both approaches without compromising the strengths of either. Another email arrived, this one from the department head, requesting a meeting to discuss my background and potential contributions to the program. Word was spreading faster than I had anticipated, academic curiosity driving administrators to investigate a student who had just demonstrated capabilities that fell outside normal curriculum boundaries. I closed the laptop and moved to the small desk where I kept the few personal items that I had carried from my military service into civilian life. A challenge coin from my EOD unit, its metal surface worn smooth from years of handling during moments of stress or uncertainty. A photograph of my team from our final deployment, 8 men and women who had learned to trust each other with their lives in situations where trust was the difference between coming home in body bags. Staff Sergeant Maria Rodriguez was in the center of the photograph, the soldier who had developed the signal reversal technique that I had demonstrated that afternoon. She had been killed by a secondary device 2 months after the photograph was taken, her knowledge dying with her except for the informal networks of EOD specialists who had learned from her innovations. Her techniques lived on in the hands and minds of soldiers who had understood that survival sometimes required solutions that couldn't be found in any manual. That was the real weight of demonstrated expertise, the knowledge that my capabilities had been purchased with other people's lives. Every technique I knew, every unconventional solution I could implement, had been developed by soldiers who had faced real consequences for failure. Sharing that knowledge in academic settings carried the responsibility of honoring their sacrifice, while ensuring that future generations of EOD specialists would be better prepared for the challenges they would inevitably face. My phone rang, interrupting my contemplation. Unknown number, but the area code was familiar. Military installations used specific phone systems, and the number pattern suggested a call originating from one of the training facilities where I had learned my trade. Sarah Vasquez, I answered, using the neutral tone I had perfected for conversations with unknown callers. Elena? This is Lieutenant Colonel Davidson, Fort Belvoir EOD Training Command. I heard you might be available for a consulting opportunity. The use of my middle name told me that the call was legitimate, that whoever had provided my contact information was someone who knew me well enough to include details that weren't part of my public academic identity. Lieutenant Colonel Davidson's voice carried the crisp authority of someone accustomed to command, but also the careful respect that senior officers showed to specialists whose expertise was valued regardless of rank. Sir, I'm currently enrolled in graduate school. My availability for consulting work is limited. I understand that, and I wouldn't be calling if this wasn't important. We're developing new training protocols for EOD specialists, specifically techniques for handling sophisticated improvised devices in urban environments. Your field experience and current academic background make you uniquely qualified to contribute to curriculum development. The opportunity was tempting for several reasons. Military consulting work would provide legitimate recognition for my expertise, while allowing me to contribute to training programs that could save lives. It would also offer financial compensation that would ease the burden of graduate school expenses and reduce my dependence on academic funding. But consulting work meant exposure, detailed background investigations and security clearances that would make my civilian academic life more complicated. It meant dividing my attention between military obligations and educational goals, potentially compromising my ability to complete my degree program within reasonable time limits. Sir, could I have some time to consider the opportunity? I'd need to understand the scope of the consulting work and how it would interface with my current academic commitments. Of course, take whatever time you need. I'll send you an information packet with project details and timeline requirements. But Elena, I want you to understand something. The techniques you developed during your deployments, the innovations you contributed to field operations, they've saved lives. This consulting opportunity would allow you to ensure that knowledge reaches the next generation of soldiers who will face similar challenges. The weight of responsibility settled over my shoulders like familiar equipment. Lieutenant Colonel Davidson was right about the importance of sharing knowledge that had been tested under real-world conditions. Military training programs were constantly evolving, incorporating lessons learned from recent operations and technological developments. My experience could contribute to that evolution in ways that would directly impact soldiers' survival rates. I understand, sir. I'll review the information packet and provide a response within a week. Outstanding. Elena, one more thing. I heard about a demonstration you gave today. Neutralizing a training device under unconventional conditions. That kind of innovation is exactly what we need in our training programs. Think about it. The call ended, leaving me to wonder how news of my classroom demonstration had reached military training command within hours of occurrence. Academic institutions and military facilities maintained informal communication networks, sharing information about personnel who moved between civilian and military sectors. My performance that afternoon had apparently triggered attention from communities that I had thought were separate from my current academic life. I returned to the kitchen window and watched darkness settle over the campus quad. Students were still scattered across the grass, but their activities had shifted to accommodate reduced visibility. Study groups had moved beneath lampposts. Conversations had become more intimate, the energy of the day giving way to the quieter rhythms of evening. My phone buzzed with another text message, this one from Jennifer Walsh, asking if I would be willing to present a guest lecture about practical EOD techniques for the Advanced Explosives Engineering Seminar Series. Academic curiosity was driving students to seek opportunities for learning that went beyond standard curriculum boundaries. The requests were accumulating faster than I had anticipated, each one representing an opportunity to share knowledge while simultaneously increasing my visibility within communities that I had preferred to navigate quietly. The careful balance I had maintained between civilian academic life and military experience was shifting, pushed off equilibrium by my own decision, to demonstrate capabilities that I had kept hidden for months. I made coffee and settled at my desk with Professor Hawkins' research papers, diving into academic literature that explored the intersection of theoretical knowledge and practical application. The papers were well researched and precisely written, but they lacked the urgency that came from understanding that theoretical mistakes could have real consequences. One paper in particular caught my attention, a mathematical analysis of optimal neutralization sequences for multi-circuit explosive devices. The author had developed elegant algorithms for determining the most efficient order of operations, calculating probability matrices for successful disposal based on device architecture and environmental factors. But the mathematical models assumed perfect information about device construction, complete visibility of all components, and unlimited time for analysis. Real-world conditions were messier, requiring disposal experts to make decisions based on incomplete information under severe time pressure. The gap between theoretical optimization and practical necessity was vast, but it was exactly the kind of gap that could be bridged through collaboration between academic research and operational experience. I pulled out a notebook and began sketching modifications to the author's mathematical models, incorporating variables that reflected real-world constraints and uncertainty factors. The work was engaging, the kind of intellectual challenge that reminded me why I had chosen to pursue graduate education after completing my military service. But as I worked through the mathematical implications of various scenarios, I was also calculating the personal implications of increased involvement with academic communities that were beginning to recognize my expertise. Each research collaboration, each guest lecture, each consulting opportunity would make me more visible, more connected to institutions and relationships that would be difficult to abandon if circumstances required sudden changes. The coffee grew cold as I worked through increasingly complex mathematical scenarios, my notebook filling with equations and diagrams that represented the intersection of academic theory and operational reality. Outside my window, the campus quad had emptied as students returned to dormitories and apartments, leaving behind the quiet stillness of late evening. My phone showed 11 missed text messages and 4 voicemail notifications. Academic curiosity and professional opportunity, combining to generate more attention in one evening than I had received in months of careful anonymity. The demonstration that afternoon had been a watershed moment, transforming me from a quiet graduate student into someone whose expertise was now recognized and sought after by multiple communities. The question was no longer whether I was ready to step out of the shadows, but whether I was prepared for the consequences of being recognized as an expert whose knowledge had been purchased with other people's lives and tested in situations where failure meant casualties rather than failing grades. Thursday morning arrived with an email from the university's public relations department requesting an interview about my background and potential contributions to the engineering program's reputation. Academic institutions were always seeking opportunities to highlight exceptional students. And word about my demonstration had apparently reached administrative levels where publicity value was carefully calculated and strategically deployed. I deleted the email without responding and walked across campus to Professor Hawkins' office, passing students who nodded with newfound recognition. The story of Tuesday's demonstration had spread through the engineering department with the speed of information in closed academic communities. Details had been embellished with each retelling, transforming a technical demonstration into something approaching legend. Professor Hawkins' office was a reflection of 4 decades in academic engineering, walls lined with technical publications and industry awards, shelves displaying complex mechanical models that illustrated principles of explosive engineering. He gestured toward a chair positioned across from his desk, his expression carrying the careful neutrality of someone who had spent considerable time preparing for our conversation. "Sarah, thank you for making time for this meeting. I've been thinking about Tuesday's demonstration, and I believe we need to discuss how your background might be integrated more effectively into our program structure." The careful phrasing suggested that he had consulted with department administrators before scheduling our meeting. Academic institutions operated through committees and consensus-building processes, and individual faculty members rarely made significant programmatic decisions without broader institutional input. "Professor, I appreciate your interest in my background, but I enrolled in this program as a student, not as a resource to be utilized for institutional purposes." Professor Hawkins leaned back in his chair, studying my response with the analytical attention he typically reserved for complex engineering problems. "Sarah, I understand your preference for maintaining student status, but your demonstration revealed expertise that could benefit other students in ways that traditional academic instruction cannot achieve. We have an obligation to provide the best possible education for all our students." The appeal to institutional responsibility was carefully calculated, designed to frame my participation as educational service rather than personal exposure. But I had learned to recognize such appeals during my military service, requests that began with organizational needs and ended with individual obligations that were difficult to refuse without appearing selfish or uncooperative. "What specifically are you proposing? Guest lectures for advanced courses, consultation on curriculum development, possibly collaboration with faculty research projects. Nothing that would interfere with your own academic progress," but opportunities to share knowledge that could enhance our program's practical relevance. Each suggestion carried implications that extended beyond the immediate academic environment. Guest lectures would establish me as a recognized expert within professional networks that extended far beyond campus boundaries. Curriculum consultation would create formal documentation of my contributions, records that would follow me throughout my academic and professional career. Research collaboration would generate publications that would make my expertise permanently visible within academic and military communities. I'll need to consider how such activities would interface with my own research timeline and academic goals. Professor Hawkins nodded, but his expression suggested that he had expected more immediate enthusiasm for opportunities that most graduate students would consider career-enhancing. Of course. But Sarah, I want you to understand something about the broader context of your situation. He pulled a folder from his desk drawer and opened it to reveal copies of academic papers and research proposals, documents that I recognized as related to explosive ordnance disposal methodology and training development. The papers were marked with highlighting and margin notes, evidence of careful study and analysis. I've been researching the current state of EOD training and academic instruction. There's a significant gap between what students learn in classroom settings and what they need to know for real-world applications. Your demonstration revealed techniques that aren't documented in any literature I could find, innovations that could improve both civilian and military training programs. The implication was clear. My knowledge represented intellectual property that could contribute to institutional research goals and professional development objectives. Academic institutions were constantly seeking opportunities to enhance their reputations through innovative programs and cutting-edge research, and my background offered possibilities that aligned with those institutional interests. Professor, the techniques I demonstrated were developed by soldiers who faced real consequences for failure. Sharing that knowledge carries responsibilities that extend beyond academic considerations, which is exactly why it needs to be shared systematically rather than informally. Sarah, if these techniques can save lives, don't we have an obligation to ensure they reach people who need them? The appeal to moral responsibility was sophisticated, framing my reluctance to share knowledge as potentially harmful to future soldiers and disposal experts who might benefit from innovations developed through sacrifice and necessity. It was the kind of argument that was difficult to counter without appearing callous or self-interested. My phone buzzed with a text message from Marcus asking if I would be available for coffee after my meeting with Professor Hawkins. Academic curiosity was driving multiple requests for informal conversations that would inevitably focus on technical details and background experiences that I preferred to keep private. Professor, I understand the potential value of sharing operational knowledge with academic communities, but I need time to consider how such sharing might be accomplished without compromising operational security or personal privacy. Professor Hawkins closed the folder and leaned forward, his expression shifting from academic persuasion to genuine concern. Sarah, I sense that you're carrying some burden related to your military experience. If there are personal factors that make public recognition difficult, we can structure any collaboration to protect your privacy while still benefiting from your expertise. The offer was generous and probably sincere, but it revealed a fundamental misunderstanding of the complexities involved in transitioning from military to civilian life. Academic institutions operated under different cultural norms and institutional pressures than military organizations, and privacy in academic settings was often more theoretical than practical. I appreciate your willingness to accommodate privacy concerns. Let me think about how various collaboration options might work within my overall academic and personal objectives. Of course. But Sarah, there's one more thing we should discuss. I received a call yesterday from Lieutenant Colonel Davidson at Fort Belvoir. He mentioned that you might be considering consulting opportunities with military training programs. The speed with which information traveled between academic and military communities was faster than I had anticipated. Professor Hawkins' knowledge of my conversation with Lieutenant Colonel Davidson suggested institutional communication networks that operated below the level of formal administrative channels. Lieutenant Colonel Davidson described a consulting opportunity that might complement my academic research interests. Military consulting work could provide valuable real-world context for your academic studies, but it would also require careful coordination to ensure that your consulting obligations don't interfere with your degree completion timeline. The practical concerns were legitimate, but they also represented institutional interests in maintaining control over student time and attention. Academic programs operated on carefully structured schedules, and external commitments that drew students away from campus-based activities were often viewed as potentially disruptive to educational objectives. Any consulting work would be scheduled to complement rather than compete with my academic responsibilities. The momentum of Tuesday's demonstration was generating opportunities and obligations at a pace that required immediate decisions about my future direction and public profile. Professor, I'll provide you with a decision about collaboration opportunities by the end of next week. I need time to evaluate how various options align with my overall academic and professional objectives. Professor Hawkins nodded and made additional notes on his calendar. That timeline works well. Sarah, one final thought. Your demonstration revealed that you possess knowledge that could significantly enhance our program's reputation and practical relevance. But more importantly, it showed that you understand how to bridge the gap between theoretical knowledge and real-world application. That's a rare combination of capabilities. The meeting ended with handshakes and commitments to future conversations, but I left Professor Hawkins' office with the clear understanding that my position within the academic community had been fundamentally altered by 30 seconds of technical demonstration. The careful balance I had maintained between visibility and anonymity was no longer sustainable under the weight of institutional interest and professional opportunity. Marcus was waiting in the coffee shop adjacent to the engineering building, his laptop open to pages of research notes and technical diagrams. He looked up as I approached his table, his expression carrying the focused intensity of someone who had spent considerable time preparing for our conversation. Sarah, thank you for making time. I've been researching signal reversal methodologies since Tuesday, and I have questions that I hope you might be willing to address. I ordered coffee and settled into the chair across from him, recognizing the academic enthusiasm that drove students to pursue knowledge beyond the boundaries of formal curriculum requirements. Marcus's questions would be intelligent and precisely formulated, but they would also probe areas of expertise that I preferred to keep private. Marcus, I'm happy to discuss general principles, but I need you to understand that some techniques involve operational considerations that aren't appropriate for academic discussion. I understand operational security concerns, but, Sarah, the technique you demonstrated could revolutionize approaches to time-critical EOD situations. If there are applications that could be safely shared with academic communities, the potential impact could be significant. Marcus opened his laptop and displayed pages of mathematical calculations and circuit diagrams, evidence of extensive research into the theoretical foundations of signal reversal methodology. His analysis was sophisticated and precisely executed, but it lacked the practical context that came from understanding how such techniques performed under real-world conditions. Your mathematical models are impressive, Marcus, but theoretical optimization assumes perfect information about device architecture and environmental conditions. Real applications require adapting techniques to incomplete information and time pressure, which is exactly why practical experience is so valuable for academic research. Sarah, would you be willing to collaborate on developing training simulations that incorporate both theoretical rigor and operational realism? The research collaboration that Marcus was proposing offered opportunities to influence how future EOD specialists would be trained while advancing academic knowledge about explosive ordnance disposal methodology. But it also represented a formal commitment to sharing knowledge that had been developed through experiences that I preferred to keep private. Training simulations could provide valuable educational benefits, but developing them would require detailed discussion of techniques and situations that involve sensitive operational information. Marcus closed his laptop and leaned forward, his expression shifting from academic enthusiasm to personal concern. Sarah, I sense that you're carrying some burden related to sharing your knowledge. If there are personal factors that make collaboration difficult, I want you to know that I respect those boundaries. The recognition of personal complexity was unexpected and appreciated. Academic environments often prioritized intellectual curiosity over individual privacy, but Marcus was demonstrating the kind of emotional intelligence that suggested maturity beyond his chronological age. Marcus, the knowledge I demonstrated was developed by soldiers who faced real consequences for innovation. Sharing that knowledge carries responsibilities that extend beyond academic considerations. I understand that your expertise was purchased at a price that most of us can't comprehend. But doesn't that make it more important to ensure that knowledge reaches people who might face similar challenges? The moral complexity of the situation was becoming clear. My reluctance to share knowledge could be viewed as honoring the sacrifice of soldiers who had developed life-saving techniques, but it could also be seen as preventing those same techniques from reaching future soldiers who might benefit from innovations developed through necessity and testing. Let me think about how collaboration might be structured to honor the source of the knowledge while ensuring its appropriate application. Marcus nodded and gathered his research materials. Sarah, whatever you decide. I want you to know that Tuesday's demonstration changed how I think about the relationship between academic knowledge and practical application. You showed me that there are levels of expertise that can't be achieved through theoretical study alone. The coffee shop was filling with students and faculty engaged in the informal conversations that constituted much of the real education that occurred in academic environments. Their discussions focused on traditional academic concerns, research projects, and course requirements and career planning activities that assumed predictable pathways through institutional structures. My phone showed 2 missed calls from Lieutenant Colonel Davidson, and an email marked urgent requesting response to the consulting opportunity proposal. Military timelines operated under different urgency parameters than academic schedules, and delay in responding to official requests was often interpreted as lack of interest or commitment. I walked across campus toward my apartment, passing students who continued to nod with recognition that had not existed a week earlier. The transformation from anonymous graduate student to recognized expert had occurred with a speed that made adjustment difficult, requiring constant recalculation of how to navigate relationships and obligations that had become more complex and visible. The afternoon mail included a package from the university's development office containing materials about alumni networking opportunities and professional mentorship programs. Academic institutions were constantly seeking ways to leverage successful graduates for institutional advancement and student placement purposes, and my military background had apparently triggered inclusion in promotional activities designed to highlight diverse career pathways. I set the promotional materials aside and opened my laptop to draft responses to the accumulating professional opportunities and academic requests that required decisions about my future direction and public profile. Each opportunity represented potential benefits balanced against personal costs that were difficult to calculate with precision. Lieutenant Colonel Davidson's consulting proposal offered financial compensation and the chance to influence military training programs that could save soldiers' lives. But it also required security clearances and background investigations that would make my civilian academic life more complicated and potentially more restrictive. Professor Hawkins' collaboration suggestions provided opportunities to enhance academic research while sharing knowledge that could benefit future EOD specialists. But they also involved formal documentation and publication activities that would make my expertise permanently visible within professional communities. Marcus's research partnership offered the chance to bridge theoretical knowledge and practical application through training simulations that could revolutionize educational approaches. But it required detailed discussion of techniques and experiences that I had learned to keep private for both personal and operational reasons. The common thread connecting all opportunities was the transformation from private individual to public expert, from anonymous student to recognized authority whose knowledge and opinions would be sought by communities that extended far beyond campus boundaries. The careful balance I had maintained between military experience and civilian anonymity would be impossible to sustain under any of the proposed collaboration structures. But as I reviewed the specific details of each opportunity, I realized that my reluctance to accept public recognition was based on assumptions about civilian reactions to military experience that might not be accurate. Tuesday's demonstration had generated respect and curiosity rather than discomfort or inappropriate questioning. Academic communities were capable of understanding that expertise developed under extreme conditions could contribute to educational and research objectives without requiring detailed explanation of those conditions. More importantly, the knowledge I possessed had been developed by soldiers who had understood that their innovations might save future lives if properly shared and applied. Staff Sergeant Maria Rodriguez had been killed before she could document the signal reversal techniques that she had developed, but her knowledge had survived through informal networks of EOD specialists who had recognized its value and ensured its transmission. The question was not whether I was comfortable with public recognition, but whether I was prepared to honor the sacrifice of soldiers who had developed life-saving techniques by ensuring that those techniques reached communities that could benefit from their application. Personal comfort was less important than professional responsibility to preserve and transmit knowledge that had been purchased with other people's lives. I opened a new document and began drafting responses to Lieutenant Colonel Davidson, Professor Hawkins, and Marcus. accepting the consulting opportunity, agreeing to limited academic collaboration, and proposing research partnership focused on training simulation development. Each commitment represented a step away from anonymity toward recognition as an expert whose knowledge could contribute to institutions and communities, that prepared people for situations where expertise meant the difference between success and failure. The transformation was irreversible, but it was also necessary. The careful privacy I had maintained since leaving military service had been a form of self-protection, but it had also been a form of selfishness that prevented knowledge developed through sacrifice from reaching people who might face similar challenges. Tuesday's demonstration had shown me that civilian academic communities were capable of understanding and respecting military expertise without requiring inappropriate disclosure of personal experiences. As evening settled over the campus and students began their migration toward dormitories and apartments, I completed my responses and scheduled meetings to discuss implementation details for collaboration activities that would fundamentally alter my position within academic and professional communities. The quiet graduate student who had enrolled at CIT seeking anonymity was about to become a recognized expert whose knowledge would influence how future generations of soldiers and disposal specialists were trained and prepared. The change was substantial, but it was also long overdue. Knowledge that could save lives belonged in communities that could apply it effectively, regardless of the personal cost to individuals who carried that knowledge. Staff Sergeant Maria Rodriguez and countless other soldiers had developed innovations through necessity and sacrifice, understanding that their techniques might benefit people they would never meet facing challenges they could not predict. My phone buzzed with a text message from Jennifer Walsh asking if I would be available for an informal study group focused on advanced EOD techniques. Academic curiosity was generating requests for knowledge sharing that went beyond formal classroom instruction, creating opportunities to influence how students understood the relationship between theoretical knowledge and practical application. I responded affirmatively and added the study group to my calendar alongside meetings with Lieutenant Colonel Davidson, Professor Hawkins, and Marcus. The schedule was becoming dense with commitments that reflected my new position as someone whose expertise was recognized and sought after by multiple communities. But as I looked around my sparse apartment with its carefully anonymous furnishings and absence of personal decorations, I realized that the transformation was not just professional but personal. The careful distance I had maintained from academic communities had been a form of self-imposed limitation, preventing me from fully engaging with educational opportunities and professional relationships that could enhance both my own development and my ability to contribute to others' success. Tomorrow would bring the first of many conversations about how to structure collaboration activities that honored the source of my knowledge while ensuring its appropriate application. The process would be complex and occasionally uncomfortable, requiring constant navigation between disclosure and privacy, between personal protection and professional responsibility. But the decision had been made, and the momentum of change was already carrying me toward a future where my expertise would be utilized to prepare others for challenges that I had faced and overcome. The knowledge developed by soldiers who had understood that their innovations might save future lives would finally reach communities that could apply it effectively, fulfilling the responsibility that came with surviving experiences that others had not. 6 months later, I stood before an auditorium filled with 300 military personnel and civilian contractors at the International Explosive Ordnance Disposal Conference in Arlington, Virginia. The presentation screen behind me displayed complex diagrams illustrating signal reversal methodologies that had evolved from Staff Sergeant Maria Rodriguez's original innovations into comprehensive training protocols now being implemented across multiple military branches. The journey from anonymous graduate student to recognized expert had been more transformative than I had anticipated when I accepted that first collaboration proposal from Professor Hawkins. What had begun as reluctant participation in academic activities had evolved into a comprehensive integration of military experience and civilian education that was producing innovations neither community could have achieved independently. The consulting work with Lieutenant Colonel Davidson had expanded beyond initial expectations. The training simulation software that Marcus and I had developed was now being tested at Fort Belvoir, Camp Pendleton, and 3 overseas installations, where EOD specialists were preparing for deployment. Early feedback indicated that soldiers trained with our hybrid methodology were completing disposal scenarios 30% faster than those using conventional approaches, with significantly improved success rates under time pressure. More importantly, the techniques were saving lives. Lieutenant Colonel Davidson had shared reports from recent operations where soldiers had successfully applied signal reversal methods in situations where conventional approaches would have required evacuation or controlled detonation. The knowledge that Staff Sergeant Rodriguez had developed in Baghdad was now protecting soldiers in Afghanistan, Iraq, and Syria, her innovations reaching people and places she could never have imagined. Professor Hawkins had been invaluable in navigating the complex process of translating operational knowledge into academic research. Our collaboration had produced 4 published papers that were reshaping how civilian institutions approached explosive ordnance disposal education. Universities across the country were requesting consultation about curriculum development, seeking to bridge the gap between theoretical knowledge and practical application that our work had highlighted. The academic recognition had been unexpected but professionally valuable. The engineering department at CIT had established a new concentration in applied explosives technology that integrated military experience with civilian education, attracting students who wanted to understand how theoretical knowledge translated into real-world capabilities. I had been offered a teaching position upon completion of my graduate degree, an opportunity to influence how future engineers approach the intersection of technical knowledge and operational necessity. But the most meaningful transformation had been personal. The careful distance I had maintained from academic communities had been replaced by genuine engagement with people who shared my commitment to advancing knowledge that could save lives. The students in Jennifer Walsh's informal study group had become colleagues and friends, their enthusiasm for learning balancing my tendency toward excessive seriousness about technical subjects. Marcus had evolved from competitive classmate to trusted research partner. His theoretical brilliance complemented my operational experience in ways that produced innovations neither of us could have achieved alone. The training simulation software bore his mathematical elegance and my practical understanding of how real devices behaved under field conditions, a synthesis that was already influencing how military and civilian institutions approached EOD education. The speaking engagement in Arlington represented the culmination of 6 months spent learning to share knowledge that I had kept private for years. The audience included soldiers who would face situations similar to those that had shaped my expertise, civilians who would design equipment and develop policies that affected operational success, and administrators who would make decisions about training programs and resource allocation. Standing at the podium, looking out at faces that reflected the diversity of communities involved in explosive ordnance disposal, I understood that my reluctance to accept public recognition had been based on misconceptions about how military experience would be received in civilian settings. These people were here because they recognized that expertise developed under extreme conditions could contribute to educational and operational objectives that served broader purposes than individual comfort or institutional advancement. The presentation went smoothly, technical content delivered with the precision I had learned through years of military briefings but adapted for audiences that included people without operational background. Questions from the audience were intelligent and respectful, focused on practical applications rather than inappropriate curiosity about personal experiences. The academic community had proven capable of understanding that knowledge could be shared without requiring disclosure of the circumstances under which it had been acquired. After the presentation, I was approached by Dr. Elizabeth Chen, a research director from the Defense Advanced Research Projects Agency, who had been following our simulation development work. She introduced herself with the casual confidence of someone accustomed to identifying and recruiting exceptional talent for projects that pushed technological boundaries. Dr. Vasquez, I've been reviewing your recent publications with great interest. DARPA is funding research into next-generation EOD training systems, and your work on signal reversal methodologies could contribute to developments that would revolutionize how we prepare specialists for emerging threats. The opportunity she described involved leading a research team that would develop training technologies, incorporating artificial intelligence, virtual reality, and haptic feedback systems. The goal was creating educational environments that could simulate the stress and uncertainty of real operations, while allowing trainees to learn from mistakes without fatal consequences. Dr. Chen, that sounds like fascinating work, but I'm still completing my graduate degree and have existing commitments to military consulting projects. We're prepared to structure the position to accommodate your academic timeline and existing obligations. Dr. Vasquez, your combination of operational experience and academic research capabilities is exactly what we need for this project. The training systems we develop could affect how thousands of soldiers are prepared for situations where your expertise might mean the difference between successful missions and casualty reports. This scale of potential impact was compelling, but it also represented another step away from the anonymous academic life I had originally sought, toward increasing visibility within professional communities that operated at the intersection of military necessity and technological innovation. DARPA projects attracted attention from media outlets and policymakers, placing participants in public positions that required careful navigation of political and institutional pressures. I'll need time to consider how such a position might integrate with my overall career objectives and personal circumstances. Dr. Chen handed me her contact information along with a classified briefing document that would require security clearance to review. Take whatever time you need, but understand that opportunities to influence training systems at this level don't arise frequently. Your knowledge could shape how the next generation of EOD specialists are prepared for challenges we can't yet predict. The evening reception following the conference provided opportunities to connect with people whose work intersected with mine in ways that suggested future collaboration possibilities. I found myself in conversations with military trainers who were implementing our simulation software, academic researchers who were studying applications of signal reversal methodology, and equipment manufacturers who were developing devices that incorporated lessons learned from our operational analysis. Colonel Sarah Martinez, an EOD commander who had served 3 tours in Afghanistan, approached me during a quiet moment between formal presentations. Her expression carried the focused attention of someone who had spent years making life-and-death decisions based on technical expertise and operational judgment. Dr. Vasquez, I wanted to thank you personally for the work you've been doing. We've been using your training protocols at Fort Carson, and the improvement in soldier performance has been remarkable. More importantly, the techniques you've shared have already prevented casualties in real operations. The recognition from someone who understood the operational context of my work was more meaningful than academic accolades or institutional recognition. Colonel Martinez had commanded soldiers who faced the same challenges that had shaped my expertise, and her appreciation reflected understanding of the personal cost that came with developing knowledge under extreme conditions. Colonel, the techniques I've shared were developed by better soldiers than me. I'm just ensuring that their innovations reach people who can benefit from their application, which is exactly why your work is so important. Military knowledge has always been transmitted through informal networks and personal mentorship, but systematic documentation and academic research can preserve innovations that might otherwise be lost when experienced personnel leave service. Our conversation was interrupted by the arrival of Dr. James Harrison, a historian from the Naval War College who was documenting the evolution of explosive ordnance disposal techniques from World War II through current operations. His research focused on how technological innovations developed under battlefield conditions influenced broader military doctrine and training methodology. Dr. Vasquez, I've been following your work with great interest from a historical perspective. The signal reversal techniques you've documented represent a fascinating example of how field innovations evolve into formal doctrine through the intersection of practical necessity and academic research. Dr. Harrison's perspective highlighted aspects of my work that I had not fully considered. The techniques I was sharing represented more than individual knowledge. They were part of a continuous process through which military experience influenced technological development and training methodology. My role in documenting and transmitting innovations developed by soldiers like Staff Sergeant Rodriguez was contributing to historical processes that extended far beyond immediate operational applications. Dr. Harrison, I'm honored to contribute to that historical process, but I want to ensure that the documentation preserves the human context of how these innovations were developed. The techniques represent not just technological advancement, but also the sacrifice and creativity of soldiers who faced extraordinary challenges. Which is exactly why systematic documentation is so important. Military history is often written from strategic and political perspectives that overlook the tactical innovations developed by individual soldiers. Your work is preserving knowledge that might otherwise exist only in informal networks and personal memory. The reception continued late into the evening, conversations flowing between technical discussions and personal reflections on the broader significance of work that bridged military experience and civilian education. I found myself engaged with communities that shared my commitment to advancing knowledge while honoring the sources from which that knowledge had emerged. The flight back to Colorado provided time to process the opportunities and obligations that had emerged from the conference. Dr. Chen's DARPA position offered chances to influence training technology development at scales that could affect thousands of soldiers. Colonel Martinez's feedback confirmed that my work was already producing operational benefits that translated into lives saved and missions accomplished. Dr. Harrison's historical perspective suggested that my contributions were part of larger processes that would influence military doctrine and educational methodology for decades. But the most significant realization was personal. The transformation from anonymous graduate student to recognized expert had not diminished my connection to the soldiers whose sacrifice had made my expertise possible. Instead, it had provided mechanisms for honoring their contributions through systematic preservation and transmission of knowledge that they had developed under circumstances that I could never fully convey to civilian audiences. Marcus was waiting at the campus coffee shop when I returned, his laptop open to pages of simulation code that had been refined during my absence. The software we had developed was evolving rapidly, incorporating feedback from military installations and academic institutions that were testing our training protocols under various conditions. Sarah, welcome back. I've got updates on the simulation testing at Fort Belvoir, and the results are even better than we had hoped. Lieutenant Colonel Davidson says soldier performance improvements are exceeding all baseline projections. The technical success was gratifying, but it was the human impact that mattered most. Each percentage point improvement in training effectiveness translated into soldiers who would be better prepared for situations where expertise meant survival. The mathematical abstractions that Marcus manipulated with such skill represented real people facing real dangers with improved capabilities. Marcus, that's excellent news. How are the civilian institutions responding to the training protocols? Professor Hawkins has been fielding requests from universities across the country. Everyone wants to understand how we're bridging theoretical knowledge and practical application. There's talk of establishing a consortium of academic institutions that would collaborate on EOD education methodology. The academic interest was expanding beyond what either of us had anticipated when we began our collaboration. Universities that had never considered military experience relevant to civilian education were recognizing that expertise developed under extreme conditions could enhance their programs in ways that traditional academic approaches could not achieve. Jennifer Walsh joined our table, carrying research materials related to her senior thesis on improvised explosive device detection technologies. Her academic focus had shifted toward practical applications after witnessing my demonstration 6 months earlier, her theoretical interests now grounded in understanding how knowledge translated into operational capabilities. Sarah, I wanted to update you on my thesis research. The detection algorithms I'm developing are based on signal analysis principles that you've shared during our study groups. My advisor thinks the work could contribute to real-world detection systems. The ripple effects of sharing knowledge were extending beyond immediate training applications into technological development that could prevent explosive threats rather than simply responding to them. Jennifer's research represented the kind of innovation that emerged when academic curiosity was informed by operational understanding, theoretical knowledge enhanced by practical context. Jennifer, that sounds like important work. Detection technologies could prevent the situations that require disposal expertise, addressing threats before they reach critical stages. Exactly. And the principles you've taught us about understanding how device builders think have been crucial for developing detection algorithms that can identify unconventional threats. Academic approaches assume rational design architectures, but real devices are built by people who want them to be unpredictable. Our conversation was interrupted by the arrival of Professor Hawkins, who carried a folder containing correspondence from institutions and organizations that had learned about our work through academic publications and conference presentations. The scope of interest was extending beyond explosive ordnance disposal into broader questions about how military experience could enhance civilian education. Sarah, I've got updates on several fronts. The Department of Homeland Security is interested in adapting our training methodologies for civilian first responders. The European Union has requested consultation about EOD education standards for member nations. And NASA wants to discuss applications of signal reversal techniques for space-based systems. Each opportunity represented different approaches to applying knowledge that had been developed for military purposes to civilian challenges that required similar expertise under different operational constraints. The fundamental principles remained consistent, but the applications were expanding into domains that I had never considered. Professor, those opportunities sound fascinating, but they would require significant time commitments that might interfere with completing my degree and fulfilling existing obligations, which is why I wanted to discuss the possibility of restructuring your academic program to accommodate these professional opportunities. Sarah, your work is attracting attention at levels that suggest career possibilities far beyond traditional academic or military pathways. The suggestion represented recognition that my position had evolved beyond standard graduate student status into something that required institutional flexibility and creative program design. Academic institutions were learning to adapt to students whose backgrounds and capabilities didn't fit conventional educational models. Let me review the specific requirements and timelines for these opportunities before making any commitments that might affect my academic progress. Professor Hawkins left the folder for my review and departed for a faculty meeting, but his suggestion about restructuring my academic program highlighted the complexity of managing multiple commitments that were pulling me in different directions. Military consulting work, academic research, civilian applications, and international collaboration all represented valuable opportunities that could contribute to my professional development while advancing knowledge that served broader purposes. The challenge was maintaining focus on core objectives while remaining open to possibilities that could enhance my ability to contribute to communities that shared my commitment to advancing knowledge that could save lives. The careful balance required constant recalibration as opportunities emerged and obligations evolved, each decision affecting not just my immediate circumstances but also my long-term position within professional communities that operated at multiple scales and levels of complexity. That evening, I walked across campus toward my apartment, passing students who continued to nod with recognition that had evolved from curiosity about an unusual demonstration into respect for contributions that were producing measurable benefits for military and civilian communities. The transformation had been more comprehensive than I had anticipated, affecting not just my professional position, but also my understanding of how individual expertise could influence institutional practices and educational methodology. The apartment had been transformed as well, sparse furnishings replaced by bookshelves containing technical publications and research materials, wall space now occupied by diagrams and photographs that reflected my engagement with academic and military communities. The careful anonymity I had maintained for months had been replaced by visible evidence of a life that integrated multiple professional identities and institutional commitments. My phone showed messages from Dr. Chen requesting response to the DARPA opportunity, Colonel Martinez inviting me to visit Fort Carson to observe implementation of our training protocols, and Dr. Harrison asking about collaboration on historical documentation of EOD innovation processes. Each message represented communities that valued my contributions and wanted to expand collaboration in ways that would enhance their own capabilities while advancing my professional development. But the most significant message was from Lieutenant Sarah Kim, a young EOD specialist who had recently completed training using our simulation software at Fort Belvoir. Her message was brief but powerful. Dr. Vasquez, I wanted you to know that the techniques you developed helped me successfully neutralize an IED yesterday in Kandahar. Thank you for sharing knowledge that saved my life and the lives of my teammates. The operational impact of academic research and military consulting work was sometimes abstract, measured in statistics and performance metrics that suggested improvements without revealing human consequences. Lieutenant Kim's message provided concrete evidence that knowledge shared through careful collaboration between military experience and civilian education was producing results that mattered in ways that transcended professional recognition or institutional advancement. I sat at my desk and began drafting responses to the accumulating opportunities and obligations that represented my new position as someone whose expertise was recognized and sought after by communities that operated at the intersection of military necessity and technological innovation. Each response required careful consideration of how to balance immediate opportunities against long-term objectives, personal interests against professional responsibilities, individual comfort against broader obligations to preserve and transmit knowledge that could save lives. The DARPA position offered unprecedented opportunities to influence training technology development, but it would require security clearances and political navigation that could complicate my academic and consulting work. The international collaboration requests represented chances to share American innovations with allied nations, but they would involve travel and cultural adaptation that could strain existing commitments. The civilian application opportunities suggested possibilities for extending military knowledge into domestic security and space exploration, but they would require learning new operational contexts and technical requirements. The common thread connecting all opportunities was the recognition that expertise developed under extreme conditions could contribute to challenges that extended far beyond the military environments where that expertise had been acquired. My knowledge was relevant to problems that I had never faced, applicable to situations that I had never imagined, useful to communities that I had never considered. But the decision-making process was guided by a principle that had emerged during my transition from military service to civilian education. Knowledge that could save lives belonged in communities that could apply it effectively, regardless of the personal cost to individuals who carried that knowledge. Staff Sergeant Rodriguez and countless other soldiers had developed innovations through necessity and sacrifice, understanding that their techniques might benefit people they would never meet, facing challenges they could not predict. My responsibility was ensuring that their contributions reached communities that could honor their sacrifice through effective application of the knowledge they had developed. Personal comfort, professional advancement, and institutional recognition were secondary considerations compared to the obligation to preserve and transmit expertise that had been purchased with other people's lives. The responses I drafted reflected that priority structure. I accepted the DARPA position with a start date that would accommodate completion of my graduate degree and fulfillment of existing consulting obligations. I agreed to limited international collaboration that would share training methodologies with allied nations, while maintaining focus on domestic military and academic commitments. I proposed civilian applications that would extend EOD principles into homeland security and space exploration, while preserving the military context that gave those principles meaning and urgency. Each commitment represented another step away from the anonymous academic life I had originally sought, but toward a professional identity that honored the source of my knowledge while ensuring its appropriate application. The transformation was irreversible, but it was also necessary. The careful privacy I had maintained since leaving military service had been protective but also limiting, preventing knowledge developed through sacrifice from reaching communities that could benefit from its application. As I completed my responses and prepared for another day of classes, meetings, and research activities that reflected my new position within academic and military communities, I understood that the journey from anonymous graduate student to recognized expert had been more than professional development. It had been a process of learning to honor sacrifice through service, to preserve memory through action, to transform personal experience into public knowledge that could serve purposes larger than individual comfort or institutional advancement. The quiet graduate student who had enrolled at CIT seeking anonymity had become someone whose expertise influenced how soldiers were trained, how students were educated, how institutions collaborated, and how knowledge developed under extreme conditions was preserved and transmitted to communities that could apply it effectively. The change had been substantial, sometimes uncomfortable, often demanding but ultimately necessary for fulfilling obligations that extended beyond personal preferences to broader responsibilities for preserving and sharing knowledge that could save lives. 6 months after accepting Marcus's challenge to demonstrate capabilities that I had preferred to keep private, I had learned that expertise developed through sacrifice carried responsibilities that could only be fulfilled through careful, systematic sharing with communities that could honor its source while ensuring its effective application. The transformation from anonymous student to recognized expert had been the price of honoring the memory of soldiers whose innovations deserved preservation and transmission to people who would face similar challenges under different circumstances. Lieutenant Kim's message remained on my phone as a reminder that abstract academic research and military consulting work produced concrete results that mattered in ways that transcended professional recognition or institutional advancement. Somewhere in Afghanistan, a young soldier was alive because knowledge developed by Staff Sergeant Rodriguez in Iraq had reached her through training programs that integrated military experience with civilian education, preserving innovations that might otherwise have been lost when experienced personnel left service. That was the real measure of success, not conference presentations or published papers or consulting contracts, but knowledge that saved lives, techniques that prevented casualties, innovations that honored sacrifice through effective application. The careful documentation and systematic transmission of expertise developed under extreme conditions served purposes that extended far beyond individual careers or institutional advancement to broader obligations for preserving and sharing knowledge that could protect people facing challenges that demanded the best of human capability and courage. The next morning brought new messages, new opportunities, new obligations that reflected the ongoing expansion of my role within communities that valued expertise developed through military service and refined through academic research. Each message represented another chance to honor the sacrifice of soldiers who had developed life-saving innovations by ensuring that their contributions reached people who could apply them effectively. The journey from anonymous graduate student to recognized expert had been transformative, demanding, sometimes overwhelming, but ultimately necessary for fulfilling responsibilities that came with surviving experiences that others had not. The knowledge I carried belonged not to me, but to the soldiers who had developed it, the students who could learn from it, the institutions that could preserve it, and the communities that could apply it to challenges that demanded the highest levels of human expertise and dedication. Standing at my apartment window, looking out at a campus where students were beginning another day of education that would prepare them for careers and challenges that I could help them understand, I realized that the transformation had been complete. The careful distance I had maintained from academic communities had been replaced by engagement that honored the source of my knowledge while ensuring its appropriate application. The quiet graduate student who had preferred anonymity had become someone whose expertise could influence how knowledge was preserved, transmitted, and applied in ways that served purposes larger than individual comfort or institutional advancement. The change had been necessary, the obligations real, the responsibilities ongoing, but the satisfaction of knowing that knowledge developed through sacrifice was reaching communities that could honor its source while ensuring its effective application made every challenge worthwhile. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.